but we will contact you later with the more detailed information about this. Okay, so basically these are some slides that you probably already received about the virtual session. And I would like to remind you that all the papers and the keynote are presented by playing a pre-recorded video, but the Q&A session are live. So you can either ask question, chatting in the left chat box, or raising your hand and talking with us. Okay, this concludes my presentation. Thank you very much for your attention, and I will pass the token to Shing-Chi, which is the first session chair of IST 2022. Enjoy your conference.
Okay, thank you, Guru. So, I would like to start, our first sessions on regression testing. So, where can I find the video to play? Should be this one, right? Sorry, I tried to play the video, but it doesn't work. So let me try again. Okay, it should be the button on the bottom, right? Play a video, right? Regression testing. Solution end to end. Thank you. So okay, we okay we have some questions. Okay, audience can type questions on the message. There is a question for the authors. Okay, from Bao. How do you see this approach can be extended to other languages, especially for multi-programming language environments?
Thank you for the question. So in general, these distributed tracing infrastructure frameworks, like OpenTelemetry is what we use, they are polyglot environments. So they usually already provide implementations for different languages, and OpenTelemetry especially has implementations, I think, for C-like languages, for Java, for JavaScript, TypeScript, and so on. So this backbone is relatively easily transferred to other language environments. Regarding the code instrumentation, it depends on the language. So JavaScript, TypeScript is fairly easy to do because they usually do source level instrumentation. When it comes to C, C++, it really depends on the kind of compiler tool chain you use. So I would argue if you have some LLVM, Clang, Linux environment, that's probably the easiest way to instrument any kind of application because they provide so many tools already. But it can be more difficult on rather specific architectures, rather specific compiler tool chains for these compiled languages. Does that answer your question?
Yes, it does. So what I have a follow-up one is like, so in that environment, basically we have like multiple VM working together, right? So how instrumentation work like across the boundary of the language? For
Across the
example, like,
bound?
but across the boundary of the language. So like for example, how the VM of Python can work together with like JVM, for example, right? So
Yeah.
you have a unique feature picture of kind of the code coverage, for example. Yeah.
Yeah, so since the backbone is unified through OpenTelemetry, it's just a matter of that you send the same kind of payload to the central, or store the same kind of payload that you send to the central collector. And the backbone is already there, the communication is already there, and it's all provided by OpenTelemetry. And you have a library for Python, you have a library for Java, you have a library for C++. So that's already taken care of. It's just a matter of what kind of information you then store when you create your instrumentation. And that would depend on your specific implementation for each of the different languages.
Okay, got it. That makes sense. Thank you.
You're welcome.
Okay, thank you. Thank you. Okay. Let's see if okay, we have other questions for the speaker. Thank you. So okay, I have a question. Okay, I know that the okay overheads is okay significant. So what are the major factors that contribute to the large overheads? Now, suppose okay one want to apply your techniques and want to reduce the overheads. What measures can they take?
So I think we saw it for the research question 1 and 2, where we looked at the performance overhead. And one major factor is already the distributed tracing infrastructure. So OpenTelemetry already puts a large overhead on the system, and you might wanna reduce that by perhaps modifying the level of instrumentation that OpenTelemetry already comes with, but that would require customizing the library for your specific language that you use from OpenTelemetry. So I'm pretty sure you can reduce the effort that is required for that specific library on your language, but I think that's just a matter of engineering effort then in the end.
True. Okay. Have you
Maybe my
considered okay?
co-author maybe has another idea
Yeah.
on
Have you
the
considered, okay, there are some methods about, okay, try to minimize the instrumentation. For example, okay, there are some work in the programming language community, okay, regarding, okay, okay, how to minimize the instrumentation, okay, so that there will be no noise. And then after the executions, one can use these techniques to recover the whole execution traces. Then I'm not
Okay.
sure whether these kind of techniques will be useful to further reduce the overhead.
That sounds interesting. Maybe you can provide a reference in the chat.
Okay, sure.
Thank you.
Sure. I will provide later. So
Thanks.
if we don't have further questions for the speakers, let's thank the speaker. Yeah. There is yes. Okay. Okay. So our next presentation. Let me stop this one. Okay. Our next presentations will be a paper on checked coverage for test width reduction. Is it worth the effort? And this is also the best paper of the conference. So let me play it.
and summarize all the findings. So the tool is available. You can use it. We compared here 3 different algorithms on 3 different coverage metrics, and we presented the experimental results obtained considering 10 open source projects. And what we see here is the checked coverage performs what is best in our study here. So thank you very much for your attention, and I'm ready to take questions.
Thank you, Franz. Okay, thanks for the very nice and interesting presentation. Now, okay, there's a question, okay, for you from the audience. Okay, how did you select alpha in the fitness function?
Yeah, so thank you very much. Sorry for being a little bit longer in the presentation. There was much content. Regarding your question, I can answer as follows. So there was so this value alpha is working as a punishment factor, and we did a pre-evaluation, and it turned out that a factor of 10 leads to the best results. This is basically why we selected it as this value.
Okay, so okay, thank you. Okay. The other thing is, okay, I find that the genetic algorithms, okay, according to one experiment, okay, offer the needs reduction, right? But okay, if my understanding is correct, the test fit after reductions, okay, based on a genetic algorithm, can offer a higher mutation coverage. Am I correct?
So, of course, if you have at least a reduction, then of course it's more likely to have a higher mutation score and be better to able to distinguish, let's say, faults from non-faults. Yes, but at least for line coverage and the standard methods for test fit reduction offers quite good capabilities, and in this way, the recommendation would go more into using greedy or delayed greedy algorithms in here. I have to say, to be frank, so we did not any optimization for the genetic algorithm. Okay, so we chose basically more or less standard values in there, and also a standard implementation. So I guess that here it would be able to do a little bit better, of course. So maybe that was not the fairest. It was more or less a byproduct. So we were interested in more in this checked coverage. My student was very curious about, let's say, the results regarding checked coverage, and so that most of the focus of this work was going on in that. Okay.
Yes, it is very interesting. Okay, the other thing is, okay, at your presentation, you mentioned, test coverage can incur high competition overhead, and that's why it may have problems to scale to large projects. So what is your advice? Okay, let's say if I am interested to use, test coverage, which, sounds like very reasonable. Should I selectively apply to certain function or certain methods rather than to the whole program?
The problem with check coverage is that we need dynamic slicing, and dynamic slicing, as all these things, they're always coming with computational overhead here. The recommendation, of course, if it is very much important to see that the assertions are really covered by test cases, or that all statements are covered by assertions, more or less, then I guess it's very much important to have here checked coverage. Otherwise, and if the programs are not too big, basically, otherwise maybe it's not that easy to come up with that in a reasonable time. So it seems this seems to be a limitation in here. But as I said, if of course you're very much interested in high coverage regarding, let's say, the what is really checked in the assertions, then check coverage is a good measure, basically, definitely.
Okay, thank you. There are two more questions, okay,
Yeah.
from the audience. Okay, the first one is from Daniel. Okay, did you consider comparing any non-coverage based TSR approach?
Not really. So we were based on these coverage methods, and we used line coverage and method coverage more or less as a baseline to be compared to check coverage.
Okay, and another question is, okay, from both. Okay, it is extremely hard to use code coverage in industry since tests are running frequently, changing constantly. So, okay, do you have any advice or comment?
Okay. So I think code coverage is I'm wondering about code about this statement, I have to say so, because many people are using code coverage. I would say for mutation score, of course, this is something different. There we have a lot of overhead as well. For code coverage, at least for line coverage and method coverage, maybe I'm missing here something in this in your question. I'm sorry on that, but
Yeah, this is just a comment because like from industry perspective, like tests are running very frequently. Like we run tests like at very few hour or even few minutes. And also it's changing constantly. So applying instrumentation it will be very challenging. And then
I see.
Yeah, that's why in industry like code coverage is very hard to implement or apply.
Yeah.
Yeah.
But
So
you mean more in a DevOps environment? So in an environment where you have really, let's say, you're producing code and then you're running it, checking it
yes.
when it is committed and so on. True, but in all these cases, I usually guess before deployment you will have a more time for testing, and in these cases before deployment, so to have, for example, a nightly build or something. Here, I would recommend to use coverage, not for the single commitments. That's right. Yes, that's something maybe wrong. Yeah.
Okay, so okay, thanks a lot. Okay, for the presentation. Thanks.
Yeah. Thank you very much.
So okay, I would like to start the next presentation. Okay, on topics on comparing and combining file-based selections and similarity-based prioritization towards regression test authentication. So let me play it.
negligible increase to the overhead. And this combined solution, it will detect failures using fewer tests in general. So it will detect the failures faster, and you can run fewer tests. You can get the feedback for the developer sooner. And it's important to note that we have used Ecstasy and Fast as a proof of concept of this idea, and they are representative of test case selection and prioritization, but they're far from the only tools that exist for that. And our understanding is that this concept can be applied to different tools. It's just that we use these two because they were available to us, and they had the implementation done.
So okay, thanks for your presentation. Okay, very interesting. And okay, I find some questions. Okay, for you. Okay, the first question is from Bo. Okay, I think it's a clarification questions regarding what does the diagram shape means. So you have some diagrams with curved shapes. So I think Bo want to clarify the meanings of those diagrams.